In this video, we're going to look at section 1.4 on exponentials. Now, a review on exponentials is just a review on exponents. You probably remember that 1 squared is 1 because it's 1 times 1. 2 squared means 2 times 2 or 4. 3 squared similarly would mean 9. 4 squared is 16, etc. So the square root is going the other direction. If we want the square root of 49, we go over here and we see that if the number b is a square root of a, if b squared equals a for any real numbers a and b, and for a non-negative. So what's inside the root needs to be positive. But here, if we have the square root of 49, we know that 7 squared is 49, so the square root of 49 is 7. This looks intimidating because it's a square root of a fraction, but we can really write this like this. Now the square root of 1 is 1, the square root of 9 is 3, so the square root of 1/9 is just 1/3. Doing this, it's a little more complicated, but we have the 2 being multiplied by the square root of 16. We know the square root of 16 would be 4, so a -2 here would be multiplied simply by 4. So our answer is a -8. And here it wants us to take the square root of -4, but that is not a real number because it says whatever's on the inside of the square root needs to be positive. So not real. Then we're going to go ahead and look at cube roots. To look at cube roots, we may want to recall some cubic numbers. When we look at cubes, one thing to note, of course, is that 2 cubed, for example, would be 2 times 2 times 2. So you're multiplying the same number 3 times. 3 cubed is 27, 4 cubed is 64. But when we cube a negative, since there will be 3 negatives, it winds up being negative. So that means that if we have a cubed root, as we're looking at here, you can have a negative number inside the radicand. So the number b is a cube root of a if b cubed equals a for any real numbers a and b. Now the cube root of a is written as the cubed root of a in this fashion, where 3 is called the index. So that little number in there is the index. If I had the 15th root of something, 15 would be the index. So taking the cube of a root, you can, if you take the cubed root of a and cube it, it just gives you a. Or if you take the cubed root of an a cubed, that gives you a also. And as it's stated here, a can be negative because when you have 3 negatives, you're going to get a negative value. Let's go ahead and see if we can do these problems here. Now, if I look at part A here, 3, I have the square root of 25n to the 4th. So looking at this, that's the same thing as the square root of 25 and the square root of n to the 4th. We can break it up that way. So the square root of 25 is 5. The square root of n/4, we're saying what times itself is going to give me n to the 4th. So many of you may already realize that that would be n squared, because when you multiply n times n, you'd add the exponents. So the square root of n to the 4th is n squared, and my answer here, as the square root of 25 of n to the 4th, would be 5n squared. Looking here, this negative is on the outside. That's totally fine. We can just bring it down. If we look at the square root of 9, that will give us 3. The square root of a to the 8th, we're thinking a to the 8th. So what times itself gives me a to the 8th? And that would be a to the 4th times a to the 4th. Because when you multiply variables, you add their exponents. So the square root of a to the 8th would be a to the 4th. Square root of b to the 10th, similarly, would be b to the 5th. So our answer here would be a -3, a to the 4th, b to the 5th. Let's do this one. When we have 36, x to the 6th, y to the 6th, we just take their square roots individually. So this will become 6. Half of x squared, or x to the 6th, would be x cubed. And here we'd get y cubed. Because, if you take x squared, or x cubed times x cubed, we would get x to the 6. Let's continue with our cube roots in example 4. Here we want the cube root of 64. Well, if you look up here, since 4 cubed is 64, we know this answer is 4. Here, if we want the cube root of 8/27, that's the same as the cube root of 8 over the cube root of 27. And using our handy dandy reference here, since 3 cubed is 27, the cube root of 27 is 3. And since 2 cubed is 8, the cube root of 8 is 2. So the cube root of this fraction is simply 2/3. Looking at this one, we want the cube root of a negative 27 x to the 12th. Well, negative 27, that's totally fine. You can have a negative 27 as the product of 3 numbers if they're negative. So this, the cube root of negative 27, is the negative 3. And here, 12, or x to the 12th, you would divide that 12 by the 3 and get x to the 4th, because x to the 4th cubed would give me that x to the 12th. So our solution here is a negative 3 x to the 4th. Let's keep rolling. Now, when we have an expression like this, there are several parts to it. We call n the index here. The little check mark here is the radical sign. What is inside the radical, a, is called the radicand, and the whole thing together is called a radical expression. So the nth root of any non-negative number is a real number. However, for negative radicands, so when this is negative, the root is not real for every index. For every index. The radicand is negative and the index is evened, then we don't have a real number. But the radicand can be negative. That's this number in here can be negative if n is odd. If the index is odd, this can be negative. Let's keep rolling. So if you have the nth root of a to the n, that will equal the absolute value of a for any even positive integer n. And if you have the nth root of a to the n for any positive integer n greater than 1, then that will equal a. What this is saying essentially is that if this is even, then you're fine with a. If this is odd, a can be positive or negative. All right, let's look at this one. The cube root is 64. We're trying to think, in order to answer this, what number cubed equals 64? And we had it listed up there. Our answer is simply 4. It would have to be positive because 64 is positive. Here, we'd be looking for what number to the 4th equals 81. And that winds up being 3. Here, we're looking for what number to the 5th gives me a negative 243. Now, it can be negative in this case because we have an odd exponent or an odd index in this case. So as it turns out, the 5th root of a negative 243 is simply a negative 3 because a negative 3 to the 5th power is a negative 243. Now, to do this on your calculator, you can do it in several ways. Sometimes you can hit math and then scroll down on your calculator until you see something that looks like this. And you can punch in your exponent and then the number in here. Or you can also do it on Desmos. If you have a question about that, you should ask your instructor. All right, let's move on to power rule for exponents. This is a review from intermediate algebra, but if you have a variable x taken to a power and then taken to another power, what this is telling you to do is you multiply the exponents. And if you're raising a product to a power, x and y, both of these variables will be taken to that power. Looking at that here, what this means, this one is like the first one. If you have a number to a power than a power, it'll equal the number to the product of the power. So in part A, where we have 5 squared, that's 5 to the 4th, or 625. Here, where we have a negative p to the 4th to the 5th, the negative just comes down, and this will be p to the 4 times 5, or 20. And here, where we have q squared to the negative 2 power, we'll multiply these because they're double exponents and get q to the negative 4th. On this one, when we raise a quotient to a power, if x is divided by y and being taken to the integer a, I think that would equal x to the a over y to the a, like that. Those are a's, not 9's. Just really make them look like a's. So x to the a over y to the a, like that. It will take each of those variables on the inside to the a power. Now, if you have a negative power, it flips the base. So if you have x over y taken to the negative a, that will be equivalent to the y in the numerator and x in the denominator taken to the a power. As that looks here, if I take a negative a to the 4th, that would be 4 negatives. So we'd wind up with a positive a to the 4th, and b to the 4th would be on bottom. Here, if we're taking all of these to the 3rd power, we'd have a negative 3 raised to the 3rd power, and r squared to the 3rd power. And when you have double exponents, we multiply them. So that will give us r to the 6th. In the denominator, we'll get an s taken to the 3rd power, and an t to the 4th taken to the 3rd. Double exponents we multiply, so t to the 12th. Simplifying this, we'll get a negative 27 r to the 6th over s cubed t squared. Now here with our negative exponent, what we learned here is that that flips the base. So this will become the same as x to the 3rd over 5 to the 3rd, or x cubed over 125.